Welcome back to Obsession Engineering and the budget rebuild of my ZXR400 road bike. First job this morning is to seal up the engine, and that means I need to replace the oil cooler with some blanks. So these are just a couple of blocks of aluminium, a couple of holes drilled in them, the edges filed off nicely, and then I've put them in the mill and milled a bit of a recess in the middle. So what I could have done was just left them plain, put some sealant on them, bolted them to the engine, and that would have sealed it up. But I've decided I want to use an O-ring to seal it because I think it's a little bit nicer, and so I've machined a dish so the O-ring can sit in there, and then I've machined it the same height as a washer, so I can put the washer in there and it stops it crushing the O-ring down and basically supports the O-ring so it actually seals properly. And so a pair of them made, took 15-20 minutes or so to make them. If I'd have gone for the sealant thing, I would have saved a few minutes, but I think this is just a little bit nicer way of doing it. So I need to bolt these to the bottom of the engine, and then I can put some oil back in it. Plates are fitted, but I did have to trim a bit off two of the corners so they didn't clash in the middle, but they are fitted, O-rings on, all done up. So the next thing to do is put oil in it. We are being cost conscious on the project, but there's one thing you shouldn't cut corners on, and it's oil. So we are using motor oil in this bike because it is the best stuff available. The bike doesn't need fully synthetic, so we are saving a little bit by putting semi-synthetic in it. It's on 1040, which is pretty much standard for most Japanese stuff. I've already put some in the oil filter, and it just lets it soak in there. Just means that you get an extra sort of half a second as it's trying to build the oil pressure up, as it doesn't have to fight its way through the filter. So the next thing to do then is bob the oil filter onto the engine, and then actually put the rest of the oil in there. So what I want to do next is put all the top end stuff back together. So the first thing I need to do is put the coils back on, but I need them to actually attach into the frame properly, so I need to sort out these well nuts. So the rubber well nuts are supposed to sit into these holes on this bracket in the frame, but they don't. So what I need to do is take the coils off the well nut assembly and see if we can get the well nuts to play ball in here. So what's happened here is the well nut has just gone wrong, basically. The actual threaded insert bit is currently at the shoulder, but it should be down here at the back, so that when you have it trapped in a piece of metal, when you screw it up, it crushes up, like squashes up, and holds the actual well nut tight in the well. But these ones have been done up too tight at some point, and it's pulled the threaded bit to the front of the well nut, and then they don't grip. So what I need to do with these is push the well nut back into the back of the well nut, down to the bottom of the well, glue them in that end, and then I can reuse them. I would fit new ones, but I haven't got any, and I'd really like to get this built. So we're into repairing. Bit of super glue into the back of the well in a couple of different places. We don't need tons. And then get hold of the well nut, got a bolt on it, and wiggle the nut back into the back of the well, into the bottom of the well, I suppose, if we're going to use the right terminology for a well. And there you go. There we have the nut at the bottom of the well, and now when I hold it in the metal and pull it, clamp it up, it'll squash that bit of rubber up there and actually clamp everything in place. Right, time to get that back in the frame. It's actually quite a faff to poke the well nuts back into the holes because they've already been expanded before. They're quite a snug fit, so new ones would have been better. But I've managed to get it in with ease. I will admit, because they are prone for falling out, I am going to wrap a cable tie around the whole lot as well and just use that to keep them in place and just help it out a little bit. It's not structural, it's a safety measure. And with the coils back on, now I can put the carbs back on in the airbox. Except I really need to take the carbs apart and actually clean them. Carbs. Plastic tray. JIS screwdriver, Japanese industrial standard. That will be useful for getting the screws out because you want a good fitting screwdriver, and a pair of long nose pliers because I'm just going to take the little pipes off that are for the hot water supply, the like antifreeze supply that goes to them, that is the carb heater, so that they don't carb ice. I'm not planning on riding it in winter. We're just going to take that off and forget about it. Apparently these carbs have already been rebuilt, so they might be minty clean inside. To be fair, the outsides are pretty clean, so I might not need to go full crazy ultrasonic cleaning. They might just want a little wipe around and put them back together, if we're lucky. Float bowls are often, it's not as clean as I'd hoped. There's quite a lot of sort of silt, dirt build up in the bottom of the carbs. And so, I don't know if all the little passages inside the carbs are going to be full of junk as well. So there's only one way to do it. Take them all apart, put them in the ultrasonic tank. So what I'm going to do next is take out the main jets, the pilot that's down there, the air screws and bits like that. Then we'll take the screw out that holds the pin that holds the float valve in place, take basically as much apart as we can. I'm not going to split them apart because my ultrasonic tank is big enough to not need to, but I am going to have to take the top caps off and take the diaphragms and bits out as well. Then the whole lot can go in the ultrasonic tank, give it an hour or two of good blasting with some good ultrasonic fluid, and that basically sends a warmer fluid through it with like a high vibration through it, ultrasonic vibration, and the vibration breaks up all the little bits of dirt and bits, and the warm fluid washes everything away, and then when you take them out of the ultrasonic, they are cleaner, the little passages inside are nice and free. Then we can put them back together and we've got a pretty good chance of the bike actually running properly. I'm happy I've made the decision to completely strip them now, because this is the outside of the float valve, and basically it sits down there and the incoming fuel has to go through this, so it's got a little like last chance filter on it and an O-ring round the side. When the float is full, when there's enough fuel in it, the float, like the float in your toilet, floats up and shoves the float valve into the bottom of here and stops any more fuel coming in, so your fuel height stays correct, the quantity of fuel in the carb stays correct. Because the O-ring is completely covered in corrosion and crud, it probably won't seal very well after several years of sitting like that. So what would happen if we ran it now is that the fuel could get past the corrosion on the outside of the O-ring where the O-ring's gone flat, and then even when the float valve closed, fuel would get past the outside of here, and then basically the carbs would overflow and the bike would run badly, and eventually it would start pouring petrol on the floor. And none of these things are ideal. So it's a good thing that we're taking the carbs apart, give them a really good clean, and we'll change these O-rings and bits as well, get ourselves one step ahead of the game. The air screw, which is here on the sort of outside the float bowl, it's worth checking when you take them apart how far out they're screwed from fully in. So, half, 1.5 to 2 turns. We'll check them all and make sure they're all the same, but basically it means when you put them back together, you've got a pretty good idea of where your air screws need to be, because that affects your mixture at idle. When you take the air screw out, you have to be quite careful, because it's not just the screw. There is on the end of it an O-ring, which is absolutely tiny, and then a washer, which is absolutely tiny, and a spring, which is not quite so tiny. So you've got to be really, really careful that you get all those bits out, because if you only take the jet out and maybe the spring, at some point, especially in the ultrasonic tank, the O-ring and the washer will fall out and be lost forever, and then it's not going to work properly when you put it back together. So you've got to be really, really careful to get all the little bits out. And around to the carb tops you have a diaphragm, a slide and a needle. So the needle goes in and out of the main jet and alters how much fuel is allowed into the carb. The slide, when it goes up, alters how much air is allowed into the carb, and the diaphragm at the top is altered by air pressure. So if we look here, we have a butterfly valve here that we open with the throttle. So when we open it, the vacuum of the engine, like the sucking of the engine, will create a vacuum up here which lifts the slide up, and that lets more fuel and more air in at the same time. That's how your carb works. These are constant velocity carbs, so basically the airspeed stays the same, because when we open the throttle, the diaphragm and slide arrangement actually sorts the airspeed out. Basically, on a set of flat slide carbs, we've just got the slide with the throttle connected to it, and we just pull the slide up by hand. What that means is your airspeed can vary loads, which means the engine might not breathe quite as efficiently at times. Now, flat slides can be a little bit more responsive because we're not waiting for air pressure changes, and because they're shorter, they can generate more horsepower, but CVs are a lot easier to live with day to day. And a couple of last things to check when we are taking them apart: make sure the needle's not got any wear on it, as it's been sort of rattling around in the emulsion tube in the main jet. It can have a little bit of wear on it. And also make sure there's no splits in the diaphragm, because if that's split, it won't hold the air pressure and then your slide won't come up properly. And this is as bare as I'm taking my carbs. I've taken the sort of inlet feeds, the bell mouths, off the front. We've got the jets and floats and everything out the bottom. Diaphragms and bits out the top. That now, as a block, can go in the ultrasonic tank along with the jets and bits for a lovely little soaky bath. 40 minutes in its lovely warm fizzy bath later, and my carb bits are looking considerably better. So I'm going to put most of it back together. And I say most of it because I have new seals for everything except the O-rings for these. And that is carbs mostly rebuilt, except there's no floats, so there's no point putting the bottoms on. But a lot of the fiddly stuff is done, so I can't lose it, basically, and the rest is sat in the tray nice and safe. So that begs the question, if we can't put the carbs back on the bike, what is the next thing to do on the ZXR? The front mudguard for the ZXR has a split up the middle of the leading edge of the mudguard, and that's only going to get worse with a bit of use. And so Adam's popped down. He has a soldering iron at the ready, and he's basically going to knit the two sides of that back together with the soldering iron.
I'm holding it closed, and then all you do is you just knit it up the line, just melting the plastic together. So you go in and then mush it around, and then when that dries it goes solid and seals.
Adam's handiwork plastic weld of the mudguard has made that considerably sturdier, and on the outside you can still see the crack, but it's now pulled it all together and made it fairly solid. And he's also gone around and just tidied up the sort of mounting points a little bit as well. So that, big thank you to Adam. Cheers, mate. Said on the instructions for the Tank Cure rust remover to leave the rust remover in the tank for several hours. Yeah, it's been in over a day, so I better empty that now, see what state the tank's in. Then the next thing to do with that is to basically rinse it out with some water, which seems an odd thing to put in a steel petrol tank, but it is the right thing. Then you have to heat the tank up to basically dry all the water out of it, and then put the next stage of stuff in, which is tank cleaner, which gets rid of a load of the residue, and then it's ready to put the sealant in. So, with a bowl handy to catch whatever drains out of my fuel tank, I'm just going to open up my sort of extra bolt I put in for draining purposes. Let's see what state this is. Yes, that's draining relatively slowly, and it definitely doesn't look a healthy colour. You'll remember not long back when we couldn't get the lock open on the tank because the mechanism had seized up, and I lubricated it and it worked nicely. Not anymore, it doesn't. Can't get the cap open. Taken the bolts out, wiggled it around, lubed the lock again, tried the spare key that I threw on the floor. Nothing works. So now I need to butcher the lock to get the cap open so that I can flush the tank out and carry on with the cleaning. Brilliant. Had to resort to drilling the lock mechanism out. It's not a pleasant job, but I am beginning to see why that didn't want to open. So, lesson learnt, next time don't use the filler cap to seal the tank up. Fuel tank has now been rust removed, then it's been cleaned, and then it's been flushed again with water, and then it's been dried again. This is a relatively time-consuming process, and now I need to mix my two parts of my epoxy tank cure together and get them in the tank, and then seal the tank up again, and then apparently spend 20 minutes rotating the tank slowly so the sealant goes everywhere. A couple of advantages to applying sealant to a fuel tank in winter. The first one is it's cold and miserable outside, so I don't want to be out there. The second one is the sealant needs to be about 20 degrees to go off properly. And so I've got about another 18 minutes of moving this petrol tank around to get the sealant everywhere, stood in my machine shop with the heaters blaring out, so this is the warmest I've been in weeks. Fuel tank is now rust free, sealant is going off, need to leave it with the heating on for another half hour or so, and then just leave it without any fuel in it for a mere 7 days. Then we can actually put it back on the bike. And hopefully by then, the bike will be ready for it. I've decided the next thing that really ought to go back on the bike is the exhaust pipes and then the new radiator and coolant pipes. Exhaust pipes refitted, the original gaskets were still in the head, but I've just given them a little smear of silicone sealant just to basically to actually hold them in the head so it's easier to assemble, and if there's any tiny little sort of leak gaps in them, the sealant will just block it up a little bit. So they're on and tightened up. I've copper slipped all the threads so that they've got a fighting chance of coming out again one day, and one of them where the stud had rounded off, the nut on the stud had rounded off, and I've got the stud out, just replaced it with a bolt. Okay, doesn't look the same as the others. Doesn't matter because you won't see it. Silencer is also bolted on, and I will admit that the adapter to get the silencer onto this one's a bit ugly, because basically these normally have a flange here with bolt holes for the silencer. Somebody's cut it off, welded a stub on, and then they can run a slip-on silencer. It is going to come off again because I've got a clamp on order to go round there to actually make it seal up, and I might change the rubber on the strap as well. Might even give the silencer a little bit of a buff up and make it look a bit prettier. I do actually have a complete another set of header pipes with the flange, and I was tempted to fit those because it's a bit more original, but then I don't have a silencer that goes to that, so then I'd have to order a silencer, and then you're adding a couple of £100 extra into a project that I'm supposed to be doing cheap. So instead I've ordered a £6 clamp. That'll do. For now. And with the exhaust pipes on, I can now put the new radiator on and my new coolant pipes. Happy days. Before I put it on though, I do need to bolt the fan onto the back of the new radiator. There is of course a problem with putting one really shiny thing on a motorbike. It makes everything around it look a little bit shabby, and so like the radiator brackets and basically the engine and all these fasteners bits, some of them don't look quite as good now that I've put something really shiny in front of it. But this is a budget project, so we're not going to go crazy stripping off stuff, repainting, replating, new fasteners and everything, because it just takes time and money that I don't want to spend on this bike. So this is a Chinese copy of a Kawasaki radiator, but I've used them before and they're actually pretty good. The mounting points are in the correct places. The fan switch is screwed in nicely. All the pipes sit at the right sort of angles. They come with the sort of clips so that you can screw the original bolts into everything. Just make sure that your fan clears so that when it runs it isn't rubbing and the actual housing isn't like fretting against the back of it. And I just had to give it, once I'd bolted it on, a little pull to get the back of the fan away from the header pipes. But that's radiator fitted. With the coolant pipes, I have blanked off the supply that would have gone to the carb heaters. And so I've put a 6mm bolt in there, but it's a bolt with a shank on it, with a non-threaded bit so it actually seals properly, and I use the original clips to hold all that together. There is another feed off the back of the engine, so I've had to blank that one the same, and it was easier to get this pipe in. That pipe was considerably easier to fit by actually taking the water sort of passage that bolts onto the back of the engine. It was easier to take that off, and then when I've taken it off it's got an oven behind it, so I've smeared a bit of sealant around that and put it back on. Trying to get the pipe in the hole otherwise was pretty much not going to happen. So that's all my coolant system bolted together, so the next thing to do is probably actually put some coolant in it. Because we only use the highest quality fluid here, we will be putting some Moto Cool into the bike, and so we'll top that in, and because I'm actually building the bike just with it sat on its side stand, it means the filler cap is actually at the top. That means the air can generally make its way out of here without me having to then lean it over again later. When we run the bike, of course, we will have to top that up, and actually before I fill that up, I am going to put the overflow pipe and header tank on it, just so that if we have a little bit excess in there, it disappears into the header tank and not straight on the bench. With the exhaust pipes and the cooling system all done on the bike and all the fluids in it, the next stage would be to make it run. Except I'm still waiting for some seals for my carbs. So, instead of that, thanks for watching, and join me again next time for some more motorbike fun.